We now find the shortest distance between the point and the plane. So here we can use this formula, that is ax naught plus by naught plus cz naught plus t divided by under the root of a squared plus b squared plus c squared, and we have to take its absolute value. So basically this point is x naught, y naught and z naught. And then I write this coefficients of x, y and z in the plane equation as this is a, this is b, that is b is -1, and c is positive 8, and d is, if we bring this -2 to this side, d will be -2. So I put d equal to -2. Now let's use this formula and find the shortest distance. So we write shortest distance, and this equals, I put a, which is 4 times of x naught is -3, plus b, which is -1, times y naught, which is 2, plus c is 8 times z naught, which is 0, plus d equals -2, and this is divided by under the root of a squared plus b squared plus c squared, that is under the root of a squared is 4 squared plus b is -1 squared, and c is 8, so it is 8 squared, and we should take the absolute value of this one. So let's simplify and evaluate this, and so we get this is -12, -2 plus 0, -2, and this is divided by under the root of 4 square is 16, plus -1 square is 1, plus 8 square is 64. We take its absolute value, and so this equals, we get -2, -12 is -14 and -16. Okay, it looks like this has to be positive 2, because p is -1, and basically this point is -2. This is -2, so therefore this will also be -2, and -1 times -2, this will be positive 2. So you can see that this positive 2 and -2 gets cancelled, and we have -12 divided by, this is 16 plus 64 is 80, 80 plus 1 is 81, so we get under the root of 81, and so this equals -12 divided by square root of 81 is 3, I'm sorry, it is 9, and so this is, we have to take its absolute value, so therefore this becomes, the absolute value of this is 12 by 9, and we can reduce this to simple fraction, that is, this is 3 times of 4, and this is 3 times of 3, so this equals 4 third. So therefore the shortest distance between the point and the plane is 4 thirds. Let's do part B. Here we find the shortest distance between the point as well as this line. This line equation is given in this form. That is, the first one is the point 5 comma 11 comma 2, and then this says the direction vector. And so I have shown the diagrammatic representation of this situation. That is, LM is the line, and P is the point 3, -2, comma 0. And the idea is to find a generic point on the line M using the line equation. And then we find two vectors, or we create the vector MP as well as the LM vector, and using the dot product we say that LM dot MP equals 0, because these two are perpendicular to each other, and from that we will get the value of t, and then substitute the value of t into the generic point M. So basically we determine the generic point M, its coordinates. Once we get the coordinates of the generic point M, we can find the distance between the point M as well as the P using the distance formula. So this is basically the idea to find the shortest distance between the point and the line. So first let's write the equation or the generic point M. So we can write down this using the line equation. That is, we have the point plus the direction vector. So therefore, I can write down this as 5 plus t times of 1 is t, and then 11 plus 5t, the point plus this direction vector, and then 2 minus 2t. This is a generic point m. Now we will write the vector mp or pm, and so this equals position vector of m minus position vector of p. The position vector of m is this vector, so we can write down this as 5 plus t and 11 plus 5t, 2 minus 2t, and then the position vector of the point p is using the point, it is 3, negative 2 and 0. So let's simplify this. This is 5 plus t minus 3, and this is 11 plus 5t. Negative of negative 2 is positive 2, and then we have 2 minus 2t minus 0. So we can simplify this, and so this equals 2 plus t. This is 11 plus 2 is 13 plus 5t. We then have 2 minus 2t. So this is basically the pm vector. Now we can write the lm vector because the line is in the direction of 1 comma 5 comma negative 2. We can write down lm equals, this is the vector 1 5 negative 2. Now using the dot product, you can see that lm vector dot pm vector equals 0. This lm vector dot pm vector equals 0, or we could yes, let's put this lm vector, which is 1 5 negative 2 dot pm vector is 2 plus t. This is 13 plus 5t and 2 minus 2t. Should find its dot product, and from this we can determine the value of t. So basically we just have to add this or multiply and add this. So this will be 2 plus t plus 13 times of 5 is 65 plus 5t plus 5t times 5 is 25t. Then we multiply this. This is negative 2 times negative 2 is negative 4. And negative 2 times negative 2t is positive 4t. And this equals 0. So let's collect the t terms. We have t plus 25t, which is 26t, plus 4t, and this equals 30t. We have a 2 plus 65 is 67. 67 minus 4 is 63. So this is a positive 63, and this equals 0. We solve for t from this equation. Therefore, we say that t equals negative 63 divided by 30, and this equals, we can reduce this to simple fraction, which is negative 21 divided by 10. So we found the value of t equals negative 21 over 10, and this means we can determine the coordinate of m by substituting into the point m. So let's do that. I copy the point m, and this equals m equals 5 plus t, 11 plus 5t, and then 2 minus 2t. Now let me substitute the value of t equal to negative 21 by t. So therefore this becomes 5 minus 21 by 10, and then 11 plus 5 times of negative 21 by 10, and then 2 minus of 2 times of t is negative 21 by 10. Let's calculate this. And so this equals, this is 50 minus 21 over 10. And this equals 11 minus 21 times of 5. This equals 105. So I put negative 105 divided by 10. This is, we have a negative 2. So it is 2 times of 21 equals 42. So it is 2 plus 42 over 10. We will simplify this. 50 minus 21, and this equals 29 over 10. So I put this 29 over 10. We can simplify this. This is 110 minus of 105 divided by 10, which is 5 tenth. This equals 5 tenth. So I put 5 tenth, and this we can simplify. This is 20 plus 42 tenths, which is 62 over 10th. So I put 62 over 10th. So basically this is the point M. We can put it this in the decimal form. So therefore M equals 29 over 10 is 2.9, and 5 over 10 is basically 0.5. This equals 62 over 10 is 0.62. So basically this is the point M which we have found now. Now we have to find the distance between this point M and as well as the point P, which is 3, negative 2, 0. So let's put this point P, which is 3, negative 2, and 0. Now we can find the distance using the distance formula. So therefore distance, and this equals, we take the square root and then do the subtraction of the corresponding components and square them. That is 2.9 minus 3 square plus the second point is 0.5 minus of minus 2. This is square, and then 0.62 minus 0 square. Okay, just need a correction here. This is not 0.62 because we have 62 over 10, and this equals 6.2. So therefore let's make this correction here. This is 6.2 minus 0 quantity square, and we can simplify this using the calculator. So we will get 44.7. We take its square root, and this is approximately 6.69, and this is rounded to 2 decimal places. So therefore this is the distance between the point and the line.